Hello. So I got the projectile management system that I was working on up and running. And usually, when I finish like a chunk of work, I'll do a quick overview of it. Think of this as like a virtual sprint review from the past couple of days' work. So I started out, I was doing a third person shooter just tutorial on how to set it up. And when we got to the part where they were shooting the gun, he was just using hit scan, so just a basic line trace. And I wanted to try a physics based projectile where I actually shot like a projectile out that could impart force and would like fly in an arcing path with gravity effects and uh, like velocity damping and things like that. So my first attempt at that was just spawning a physics object and punting it with great speed in the direction that the rifle was facing. But I quickly realized that the hit detection for that was really, really bad. And also, we want to have something that's like performant and runs quick and can handle potentially thousands to tens of thousands of projectiles at the same time. So I looked around and I found somebody mentioning like a projectile management system, um, which is what I went and implemented. So I'm going to show kind of the way the pieces of that work together, how they work, how we can control like the projectile behavior and things like that. And we can just see kind of where we're at. So I have all the movement stuff that I set up on the third person character pawn. There's like some issues, but it's fairly responsive. It feels pretty good. We ADS, crouch ADS, ADS, un ADS, ADS. So I don't have a reticle, like a targeting reticle yet or anything like that, but so you can see that we have basically a line trace, but it's following an actual arcing pattern here. And we can control like the initial velocity, we can control the gravity, and we can control the linear dampening of the speed of the particle. So, and there's it's performant. We can have a whole bunch of projectiles at the same time without having any kind of slowdown whatsoever. There's hundreds and hundreds of projectiles all at the same time. And we're still getting like hit detection and things like that. The projectiles have information about like their velocity and things like that, so it's also possible to use the velocity to modulate the damage. And we have the ability to handle hits on objects that we care about. So in this case, you can see the damage going down there. That's the health of this dummy. So we're kind of chipping the health down. And now it's a negative, so it would be dead. You can also see that after these projectiles impact, they stop tracing. And also we have like precise hit locations on the character mesh here. So if we wanted to use like blood splatter or like dismemberment or anything like that, we could do it pretty easily. We also have the capability to, like for instance, if we wanted to do a projectile that arced up and then came down and exploded into a lot of other projectiles, we could set that up pretty easily with this system. If we wanted to do like a fragmentation grenade or a shotgun, um, we can just add more projectiles. So we could have it like explode out in a fragmentation pattern here, or if we wanted a shotgun, we could have it shoot, 8 or 16 pellets when we fire one shot. I haven't done any like death animations or anything like that. This was all really about just setting up this kind of projectile management system where we can have like bullet drop and like bullet slowdown and over distance and things like that. And right now the bullet drop is like the damping is actually tuned really high. And that's because I wanted to be able to test it and make sure it worked. So looking at that, we'll hop into what I built here. So it actually, the implementation of this consists of two blueprints, two structs, and this I need to actually delete. Force delete. And then we will. Nope. I want to see the error, please. Nope. What the fuck? Okay. Well, I crashed the blueprint. We'll get it fixed. So basically, we have. Skip the restore. We can fix it. And my dog is going nuts. So, let's pull this back up. Point. All right, we're back. So we're gonna blame that one on. Nope, this is wrong. Delete this. Yep. We actually, I don't think we need this anymore. We just don't need the function. All right, now we build again. Make sure everything works still. All right, we're good. All right, so let's go over the pieces of this puzzle because it took a little bit to figure this out. So, first of all, let's kind of talk about the architecture. Um, so we basically have a projectile manager folder. We have a blueprint, projectile manager, actor blueprint. We have a actor component, projectile weapon blueprint, and we have two structs. Projectile environment. This is like environmental data that affects the projectile, like gravity information, wind information, dampening of movement value, things like that. We could also put like other information in this that if we want to if we want to basically have you shooting your gun in space, you could have the bullets behave differently than they do on the ground and things like that. So what we'll do is start by taking a look at the environment. So right now I just have these four, but we have the ability to expand this and add more, which is really useful. We have gravity, acceleration, and direction, wind force, and damping. I'm not using wind force right now. I just know that it's potentially something that we could use, so I added it as an example. Um, Gravity, direction, and acceleration are like probably going to end up being snapshotted from the player because I want to do a custom gravity system. Um, so like whenever the player shoots the gun, we'll sample the gravity at the player, and then that'll apply to his projectile, something like that. I haven't thought too deep into it, but yeah. So we have a magnitude and a vector, and a damping value. Okay, next. Okay, this is the projectile struct. So we have position, velocity, lifetime, distance traveled, mass, damage, max lifetime, max range, is alive, environment data, which is that struct we just looked at, and owner, which this is like who fired the projectile. Okay? So this is our two structs, our data models that we're working with. Let's take a look at the projectile manager. All right, this is the projectile manager. We have uh, currently basically only one way to interact with this, although I do want to add a way to add a collection of projectiles. And actually, we can do that right now. It'd be a good demonstration. So just do custom event, um, add tiles, and this will take a projectile struct array. New projectiles. All right, so now we have the ability to add a single projectile into our managed projectiles, or we can add um, is there a UE5 blueprint add array items to pinned? There it is. Easy peasy. And this would be, for example, okay, so quick example of why we might want this. So for like an automatic gun that we were just shooting, generating one projectile at a time is fine. But let's say we wanted a shotgun. Well, rather than having the shotgun have to come in here and call add projectile 8 times, we could just make an array of 8 projectiles and pass it to this. Or say we wanted to create a fragmentation grenade, right? Um, Same idea. We could create a fragmentation grenade, add it to uh, generate a bunch of randomized projectiles with like random directions that are going to shoot out in a sphere, maybe like 100 projectiles, right? And then we could just pass that array that we proceduralized into this function, and it immediately gets appended into the managing array. So how does this work? So basically the responsibility of this class is to do the projectile management for the entire game. Um, and the way we do that is we define a projectile struct at the time that we want to shoot it. And that requires a couple things. We need to know the origin position of the projectile. Where is the projectile right now? In our case, we can just use the muzzle of our gun, or I'm using like the muzzle flash location. And we need to know the direction the projectile is going to go. Again, can be derived from our skeletal gun asset. And then finally, we need to know the force that the projectile is going to be fired with. How fast is it going to go? And then aside from that, we need all the kind of meta information. Lifetime, which will always be 0 when starting. Distance traveled, always 0 when starting, so you don't need these two. Mass can be set to whatever you want. I'm not using this currently, but you could use this, for instance, to impart force based on the mass and velocity. You could impart realistic amounts of force into the model. Damage, this is like your base damage. Max lifetime and range, these you will define. You can just define them as very large values. Like I have it, I think 20 seconds here, and the max range is like like a million units or something like that. Is alive is our flag when so this processor basically does two loops. The first loop, it goes through our array. The first loop on the event tick, it goes through our array of projectiles and it updates all the projectiles to their new locations and does a hit calculation for each one. And then the second loop goes through the array and removes any projectiles that are flagged as not alive. Environmental data is broken out right here. We're using gravity, acceleration, direction, and damping. And then the owner is used to assign, like, who shot you. Assign blame, basically, right? So, what we basically do is we have two loops here. Um, and this is actually a pretty good opportunity for me to organize this stuff a little bit better. Because this is the guts of the operation. This is the most important part. And this looks pretty complicated, but I'm going to go over kind of what's going on here. And it's not too hard to understand. So the first thing we do, calculate, calculate updated projectile data. So the first thing we do on the event tick, we set our delta time because we're going to use this in a bunch of our calculations, and then we loop we loop all the projectiles we have, and we're doing this in one big batch instead of having each projectile doing its own independent loop because it's just more efficient this way. We can batch everything. These are relatively inexpensive calculations, and so even if we were looping like 5 or 6 thousand times, which you would be very unlikely to have 5 or 6 thousand projectiles in the air at the same time in a single game. But even if you were, this would handle it. I suspect it would handle it just fine, because I did some tests with very low cooldown on firing, and you could make it like a Vulcan or like a CRAM, and it runs just fine. Okay, so what are we doing here? So basically, for each projectile in our array on every event tech, we're going to, let me draw it. So we have a big box of projectiles. Projects. So for each of these, what we have is basically last frames data, and we want to calculate this frames data. Once we have these 2 points, we can bounds check distance versus max distance and lifetime versus max lifetime. If it fails, fail. Then we're going to set is alive false. If it succeeds, then we're going to do line trace from last projectile position to updated position. And now hit something. Did not hit. If the projectile did not hit anything, we simply place updated projectile data into managed array. If it hits something, set is alive false. Invoke hit callback on owner. And then place updated node, updated projectile in array. To next loop cycle. And place updated projectile to array. All right. So this is the whole life cycle of our projectile updates. These 2 functions then converge on a second loop. equals false. Remove proj from managed array. So after we've done all our updates and calculated our hit scan and everything, um, we do a loop. If we find any proj structs in our managed array where is alive is false, this stage is going to remove the projectile from the managed array, and then we're done. And this happens on every frame. So let's talk about, so this is calculate updated projectile data. 1 second. Hey, Teddy. All right, sorry about that. So you can see we've basically broken this up into the segments that we were just talking about. Let's make this full size. And we'll talk about what we're calculating here. All right, I'm back. Sorry about that. So, so we've gone over kind of the structure here. Um, the other thing that I failed to mention is I've added an instance of this object to the game mode blueprint in a function to fetch it off the game mode. So as long as I'm in third person game mode, you can fetch a singleton projectile manager. All the projectiles go into the same object, manages them all. All right, so again, this was the flow here. Let's go take a look at the actual implementation. So what are we doing here? Well, we're taking projection, position, velocity, um, mainly position and velocity, and we're also taking gravitational acceleration, direction, and dampening. So right here, we're calculating our velocity dampening factor. Right here, we're calculating. This is calculated by the initial velocity times the dampening times the delta time times -1, and this gives us a basically fraction of our velocity that over the course of 1 second we will lose that amount of speed. So like right now I think I have dampening set to like 9 or something silly like that. But that was just a kind of test, like 0.9, which means that after 1 second it would have lost 90% of its velocity. That's not really realistic, but I was doing it to make sure all this stuff works. So we calculate the velocity damping here. We calculate gravitational acceleration, and this is calculated by the gravitational acceleration times the gravity direction times the delta time. And then we calculate our modified velocity, which is going to be our original velocity plus the dampening factor plus the acceleration from gravity. Then we calculate our frame position change, which we have a delta here, which is our modified velocity times our delta time. This will give us the amount of change in world units between the current position and the last position. And then finally, we have our final position, which is our original position plus the delta. Um, we update our lifetime, which is just taking whatever the lifetime was, appending the delta time to it. We update our distance traveled, which is taking the distance, the vector length of the frame delta, and adding it to our existing distance traveled. These all get set in these top four. Mass and damage remain unchanged. Max lifetime and max range remain unchanged. Is alive, we calculate by checking the lifetime current value and making sure that it is not greater than the max lifetime. Likewise, the distance must not be greater than the max range. And finally, that is ANDed with the existing is alive state. And this goes into our is alive. And that handles our max lifetime lifetime exceeding max lifetime case, as well as our distance traveled exceeding max range case. So we can set kind of boundaries on how we want our projectiles to look or go. A great example of this would be like if we wanted to do a fragmentation grenade and we wanted to generate 100 projectiles, but like in a game you don't want it to work like it would in real life because it'd be really fucking OP, right? Because the grenade could kill you from very far away. um, so if we want to have, say we want our grenade to have 100-foot radius, or like a, let's say a 20 meter radius or something like that, then we could set our max range to 20 meters, and that would stop our projectiles from going beyond that range without dying. Um, Finally, once this is all calculated, we set this into a current projectile placeholder value. So now we have our projectile from last frame right here and our updated projectile from this frame. And this is coming down here and hitting a branch, and it's checking the is alive of the updated projectile. So if the projectile was flagged to dead, we don't need to do the line trace because the projectile is already dead. So we just don't need to do that anymore. So we're going to short circuit out of that if that is the case. All right, next we take the position from the original projectile and the position from the updated projectile. We set those at the start and end of our line trace. Trace channel can be whatever you want, but I will say that if you want to have the precise hits on the actual character model and not the capsule component, where like you could have like nice blood splatter effects or hit effects or dismemberment or things like that, then you are gonna want to go into your third person character that this stuff is being appended to, go to the capsule cylinder, seek out collision, and you'll see here that I've turned visibility and camera trace responses off. You only have to do whichever trace you're using, but I just turned off both for good measure. And then you're going to want to come to the character mesh, and you're going to want to turn. Right now I have camera traces on because that's the one that I'm using. You could also switch this to custom and put visibility trace on. I'm not sure 100% what the differences between these two are, but for my purposes, the camera trace is working fine. So whatever. Um, I wonder. Hang on. Let's test that actually. If I shoot something in this way and then I turn around and turn back, yeah, it stays. All right, it stays. This is like our Vulcan minigun. It's just fun. It's like a spirograph. Okay, so back to yeah. So I use a camera trace, so you can see the trace response to camera is here. Um, I don't remember if I had to use complex as simple collision. I don't think I did. No, maybe. Um, let's actually try this because I might not need the complex trace. You're gonna find out. Yeah, it looks fine. You don't need trace complex collision. Um, so I'm turning it off. Okay, so we're back here. We have our projectile from last frame and our projectile from this frame. We're taking the start and end position of that. We're doing a line trace, and we're checking on if we had a hit or not. If we had a hit, okay. If we had a hit, we're setting the is alive in our current projectile struct to false. And then we're breaking out this projectile struct and getting the owner object, and we're invoking the process hit method. And this owner object is a BP projectile weapon object, and I'm going to show that that struct next, or that class next. So we're guaranteed to have this process hit method. This process hit method takes the projectile data object, so it's just this updated current projectile, as well as the hit data that was generated by this function. And then you can, in your weapon, this firing the projectiles, you can implement this however the hell you want. Finally, it's rejoining here to set the array element in manage projectiles for the index of the loop that we're on to the current projectile. So we're basically overwriting the old projectile with the newly updated projectile from this frame. And then next frame, this is all going to repeat again. It's going to get updated again, overwritten again. If there was no hit, we don't need to do any more updates. We just immediately update. We don't need to do any more like updates to the struct itself. We just need to immediately overwrite it in the array, and then we're done with that branch of the loop. So this ends the like projectile update loop. Finally, when this loop is complete, we come down here and we do one more loop for each projectile, we're checking if it's alive. If it's not alive, we're just removing it from the array, and that's it. So that's the entire projectile manager. So any projectile, and there's all kinds of stuff that I still would want to add to this. Like you probably want the ability to have like a mesh object to be the projectile, and this could also handle like repositioning those mesh objects and things like that. Like what if you had a rocket launcher, right? You could use a physics-based rocket launcher. You could add a physical projectile that you could see, or even bullets. Any of this could be added in. We would probably add like a static mesh field to our projectile, a nullable static mesh field to our projectile struct. If it's present, then we would update the like create a maybe a particle system or something to do it, and then set the mesh to the mesh that's part of the projectile struct. But this was kind of just a proof of concept. I haven't gone that deep into anything yet. Um, so yeah, we got add projectile, add projectile, add projectiles. We do one loop which updates the takes the last frame's projectile, calculates this frame's projectile location information, does a line hit trace, basically does the update from the hit trace, and then invokes the hit callback on the owner objects from the which will be our projectile weapon, by the way, and then finally updates the projectile in the array, and then we have our last loop here to clean everything out. So that's pretty much it for the manager. And then the way we do this, if I go to third person here, I go to blueprints, we have this third person game mode. So in here, we go to the event graph. There's nothing here, but you can see in the default scene root, I've added a BP projectile manager to the third person game mode. And then I've added a function, get projectile manager, which takes this object from here, gets its child actor, casts it to the thing that we need, and returns it, or returns a null. So this is so then whenever we need the projectile manager, which we use over here somewhere, yeah, right here. So like this is my basically proof of concept. You could implement any number of guns like this, but this is just SIG 1. So we call it get game mode. We cast it to a third person game mode, which is the game mode we're adding. You could do the same thing with first person. Like there's no inherent reason why this projectile manager system could not work with any game mode. I mean, it could be you could use this to track projectiles in an ARPG. You could use this to track like you might have to change the like projectile calculation logic to work the way you want it, but like the idea of having a manager that manages all your projectiles, I think, is probably a fundamentally good one. So once we've casted to this, we have that get projectile manager function, and we just set an internal reference here. But the idea is that this manager is a singleton. So like if I shoot at my dude over there and he shoots at me, we're both submitting our projectiles to the same projectile manager, and those projectiles are both getting updated on the same tick at the same time. So like um, there's no like lag discrepancy or anything like that. It's just they're happening at the same time because all the projectiles are being batch processed. All right, so we set up our reference to projectile manager, and let's just take a look at the functions here. So this is basically, let's take a look back to projectile manager. It's a actor component class, skeletal mesh component class. If we take a look here, you can see we've added it, and there is a skeletal mesh object so we can add whatever asset we want to use here. I'm using this assault rifle A that was a part of a free pack of guns that I downloaded. This gets socketed in. Like there's a whole tutorial on like setting up like holding the gun and things like that. Basically, I take this projectile weapon thing and we could override this and make different versions of it with different assets, and I attach it to the right hand socket. But all of that is kind of setting up the third person character game mode, and I'm more concerned about talking about the projectile manager that I just finished. So we'll go back over here and we'll take a look. So as long as we have a valid projectile manager, so we have a, let's take a look at the events we've got here because there's only two, I think. Yeah. So begin play, we set up our reference to the projectile manager. We have fire and we have process hit. And I want to do some work here because right now my auto firing is being handled outside of the weapon and I want it to be a property of the weapon. But anyway, I'll approach that after I shut down this kind of review video because I'm going to be working on a gravity system in a few minutes. So fire. Do we have a projectile manager? Yes. Okay, great. Play the animation for the firing the rifle and get the socket transform of the rifle's muzzle flash. These are specific to the object that I have loaded and I'm using, or at least the asset pack that I'm using, but you would have a similar logic on basically any weapon, I think. You would have the animation for the weapon firing and some object that you're going to pick up from the weapon to determine like orientation data. We also have a default projectile. And the way this works is the magnitude of this vector is going to determine our initial velocity. So here you can see we have, this is in centimeters per second. So this is 100 meters per second, which is like a paintball maybe, which is why we can actually see them moving because they're going at like paintball speeds, right? Um, but we could tune this, like say we wanted it to go rifle speeds, right? Um, well, rifle speeds would be more like 1,500 to 2,000 feet per second. So let's see, 1,500 meters per second. That's actually too high because I was thinking feet. It'd probably be more like 800. But yeah, so like there's much less drop here. They basically go until they get fully dampened and then drop. Um, the damping there might need some work too, but I'll figure it out. All right. So I get the socket transform of the muzzle flash here, and I'm getting its orientation, the forward vector from its rotation, as well as its location. We're going to use its location to spawn our projectile for this shot. We're going to use its orientation direction um, times the default projectile's velocity to get its initial velocity or its magnitude, right? So we have our initial velocity that we were just looking at. This is how we control our projectile speed. We get the vector length of it. We multiply that by the forward vector of the rotation of the component that we're using to get our orientation from the weapon. Um, Everything else is plugged in to be set. This Everything else except owner is plugged in from our default projectile into the mirrored nodes, and then our self is plugged into owner. So like this gun will become the owner of this projectile, right? And then all we got to do, we don't have to do any kind of projectile manipulation within the gun blueprint. We don't have to do any of that. All we have to do to generate a projectile is get our projectile manager and call add projectile. And from that point on, the projectile manager is responsible for handling the life cycle of that projectile. And then likewise, our other function is process hit. And this is what we do when one of our projectiles that we spawned and set ourselves as the owner of have hit something. Um, so we get the projectile data here. I break ST projectile to get, well, we'll leave mass because it might be relevant here. We take the initial velocity that we imparted from the project. I'm taking the initial velocity that I imparted to the projectile. So this was our 10,000 or whatever. Right now it's like 15,000, which I'm going to change. 150 meters per second. Um, yeah, so we take our, basically this amounts to our maximum velocity because you're not going to gain velocity after you shoot the round, right? We take our, wait, is this wrong? Yeah, this is wrong. So I fucked up here. This this makes sense. This doesn't. So position is the wrong thing to be taking the vector length of here. We want velocity. So this is great because I get to find my own mistakes. And that's also why my damage calculations were so low, probably. Yeah, see, they're way higher damage. Okay, great. So that actually solves the mystery because the bullets were supposed to have 100 default damage and they were hitting for like 20. Okay, so basically, what we're doing here is we're checking the velocity versus the max velocity and normalizing it into the 0 to 1 range, and then we're using that as a multiplier to our base damage. So the more our bullet is slowed down, the less damage it's going to do. Finally, so we calculate the velocity ratio times the damage. We get the owner object. We also get the hit result here. This is going to show our hit actor. We attempt to cast the hit actor to a third person character, which we know we have damage values in. And if we succeed, then we're going to apply point damage with the damage we calculated up here, the actor that we got from our hit data, the normalized velocity as the direction that it was hit from, because our velocity would be like basically which direction are we moving in currently. Um, we get the owner of the owner of the owner. So this would be third person character, the owner that's carrying the rifle, and we set that in the damage causer, and we get the instigator controller into the event instigator, and then we apply this apply point damage to our third person character model. And then finally in the third person character model we are tied into on take any damage. We're just taking the damage right now, subtracting it from our health, setting our health, and printing our health out to the screen. Our health is starting at 1,000, just for reasons, just to test. So that's pretty much the whole system. I realize that that is a lot, but the main gist is that you don't shoot projectiles from the gun. You generate a projectile data struct and you submit that to a centralized projectile manager that lives in the game mode. The projectile manager takes over the life cycle of that projectile, and basically changes the projectile location each time, but not doing a like, oh, I'm here now, let me do a collision check. It does a line trace check for each segment of the line. So rather than having an like a physics object that you propelled really fast and like it just phased through the object because it was going too fast to register the hit, we have like a contiguous line of line traces that will always basically generate a hit if it crosses an object, no matter how fast it's going. And like to the point where if we wanted just a hit scan weapon, we could do that. We just go into our projectile weapon, go into our default projectile, set our velocity to just like some ungodly huge number. And now what we basically have is a hit scan weapon. Well, that's interesting. Okay, maybe that was too much. I guess there are limits. Let's try this again. There you go. So basically, yeah, we have a hit scan weapon. It's just like weaving the bounds of like the clipping area that we. No, it's actually hitting the max distance, is what's going on here. Oh, you know what? That's what was happening before. We were hitting the max distance instantly and destroying the projectile. Like in one frame, we were hitting max distance. But what we basically have here is a hit scan weapon, right? There is no delay because it's so fucking fast. But even though it's hit scan, it still has some physical components, and it still properly intersects the player model, which is really cool. You can see how far it's traveling in a single frame. Yeah. It's just like it's going the whole way in a single frame. So I guess whatever velocity we give it, we just can't give it a higher velocity than our max distance. And as long as we do that, we're going to generate hit events on whatever we hit. We don't have the, and we can do this like we have physics, you know? We have the ability to apply physics. We have the ability to apply custom physics. If I wanted to flip the gravity direction or have a random ass gravity direction, we could do that, which is kind of part of the goal of this was that I wanted to also have the ability to say have a character get out, walk around on a planet, and shoot a gun, and the projectiles are affected by the planet's gravity, and then get on their spaceship, which might have a slightly different gravitational profile, and then move around inside their spaceship while it's flying around, and also shoot their gun on the spaceship and have it act properly. And then finally, they should be able to jump out into outer space while they're in no gravity, and their gun would behave differently yet again. We can do all that with this. So it's pretty cool. I'm pretty happy with the results of this one. Um, this is one of the things where like I was sure I was gonna have to face bash on it and debug it, but it kind of just worked once I got all the pieces put together, which is rare. So enjoy when that happens. Um, so yeah, that's kind of an overview of my last. Did I spell this wrong? No. It's just stupid. So that's kind of an overview of my last couple days of futzing around with projectile systems. I am about to pull the stream down and bring it back up again. And when I come back, I'm going to be working on nested gravity systems. So, gravity systems and frame of reference. So, I'll be back in a minute.